Let's consider multiplication of a vector. Basically, when we are talking about multiplication of a vector, we basically talk about two forms of what vector multiplication. Now, the first form of vector multiplication is what we call the scalar product or dot product. So you can call it scalar product, or better still, you can still call it what? Your dot product. Now, how do you represent your scalar product or your what? Your dot product? We basically, let's say we have two vectors A and B, and we want to represent those two vectors using what? Dot product, right? How do you now represent those two vectors? We simply represent the vector A and B in this manner. So basically have A multiplied by what? B. Now looking at this is A multiplied by B, and this form of vector multiplication should tell you that, okay, we are talking about what? Dot product, or better still, scalar product. Now what's another type or another form of vector multiplication? Now, another form of vector multiplication which we know is basically called your vector product, or better still, your cross product. So you can call it vector product, or better still, you can call it what? Your cross product. Now, how do we represent our cross product? Basically, we represent our cross product in this manner. So we have A cross what? B. Looking at this vector multiplication, this is telling you that A multiplied by what? B. But in essence, looking at this will tell you that, okay, you are talking about what? Vector product. This is telling us that we are talking about what? Scalar what? Product. Now, what's the unique thing about your scalar product and your vector product? Looking at this product, looking at the first one, which we have to be our what? Our scalar product. From the word scalar, scalar is telling you that it has what? Magnitude without what? Direction. So basically, the unique thing about your scalar product is basically it's having what? Magnitude, but no what? Direction. So basically, what your answer should look like should only have what? Magnitude. Am I communicating? But when we are now considering our vector product, vector simply tells you that, okay, we are going to have your magnitude and your what? Your direction. Now, what's your direction in this case? The direction which we consider in this course is what we call our unit what? Vector. Am I communicating? The unit vector is the IJK. So those are what? Those are our directions. Am I communicating? So basically, your the unique thing you are seeing for a vector product is basically what? This product will basically have magnitude, not just magnitude, but what? Direction as well. So basically you're having magnitude and what? Direction. Now let's dig deep into our scalar, or what? Our dot product. Now take down scalar or your dot product. Scalar or your what? Your dot, sorry. This should be dot product. So basically have what? So we have what? Scalar or your what? Your dot product. Your dot product. Now remember, we're talking about what? Cartesian plane. That's what we'll be considering. Since we are considering Cartesian plane since the course started, our interest to be what? IJK, right? IJ what? K. Now, what if we have two directions or two unit vector multiplying what? Itself? What if we have two unit vector multiplying itself? What do you think the answer will be? So let's say we are considering a plane. In a plane, so you can take down, in a plane where we now have two unit vectors multiplying itself. What is our answer? Now take down, note, when we have two unit vector with the same quantity multiplying itself for a scalar vector, that unit vector, your answer will simply be what? 1. I come again. When we have two unit vectors of the same quantity multiplying what? Itself, your answer becomes what? 1. So basically, if we have two unit vector, look at, we have quantity 1, quantity 1. They are multiplying itself. Since they are multiplying themselves together with what? The form of what? Scalar what? Product. We'll simply have this to be what? 1. That's the concept. Now, what if we now have two unit vectors that are not the same multiplying itself, that simply gives you what? 0 is another concept. So I've given you two concepts. The first one is when you have two what? Two vectors, two unit vectors multiplying itself with the same quantity, it gives you what? A constant, which is what? 1. But when you now have different vector, unit vector, different unit vector multiplying itself, that gives you what? 0. So basically, if you have I multiplied by I, this is giving you a constant, which is what? 1. What's the next one? The next concept is if you have I multiplied by what? J, what will you simply get? 0. If you have I multiplied by what? K, what will you simply have? 0. Apply that same concept for what? J and K. So basically, the first thing you have is J multiplied by what? I. What do you think the answer will be? 0. J multiplied by what? J. What do you think the answer will be? 1. Why? Because they are having what? The same quantity and they are the same what? Unit vector. Am I communicating? What's the next one? J multiplied by what? K. And what will this give you? What? 0. What's the next thing? The next thing is what? K. K multiplied by what? I. What will you have? This will give you what? 0. K multiplied by what? J. This will give you what? 0. And what? K multiplied by what? K. And this will give you what? A constant, which is what? 1. So you can see that diagonally, you have what? 1 as your answer here. Diagonally, you have what? 1 as your answer here. So if I'm you, I will quickly note this and this will be part of me. So in essence, in a case where you're now asked what is I multiplied by J, you can simply what? Deduce your what? Answer if you are giving a very simple example. Am I communicating? Now let's take some examples. Take down example 1. Example 1. For example 1, we're given A is equal to what? AXI plus what? AYJ plus AZ what? K. So we are given another one, B to be BXI plus what? BYJ plus what? BZK. How do we go about it? You are now asked, what is A dot B? Simple question. What is A dot B? How do you go about it? These are exam questions, so take note. These are what? Practical what? Exam questions. So don't skip these steps. Are we together? So basically, if you want to solve this, the first thing you do is we're having what? They are telling us to show what is what? A dot B. Show that this is a what? This is a what? A scalar what? Product. Showing that this is a scalar product, show that this will have what? Magnitude without what? Direction. Am I communicating? Now let's go there. Let's say we have two vectors, A multiplying another vector, B. So we have two vectors, A and B, multiplying itself using the form of what? The scalar product, right? If we have this, how do we go about it? This is simply telling us that we have AXI plus what? AYJ plus what? AZK multiplying what? BXI plus what? BYJ plus BZK. What do you do? Remember, when we had 2x plus what? 3x or 3y, and we have 2x plus what? 4y. What do? What we do is we use this to multiply everything here. Then we now go back and use this to multiply everything here. So what we are doing is simply what? Applying this concept here. So basically, we are simply applying this concept here. What are we going to do? Now, this concept is simply telling us that we are using one of these to multiply everything here, We will now come back and use one of these to multiply what? Everything here. Then we will now come back and use one of these to multiply what? Everything here. Am I communicating? Look up, listen. Listen. Now, if we have AXI multiplying everything in this bracket, this will simply give you what? AX multiply by this. So what you do is you keep the constant aside, then you pick AX multiply by what? BX. So basically this will be what? AX multiply by what? BX of what? I multiply by what? I. This is I here, this is I here. That's the meaning. The next thing is pick this, multiply it with this. So if you do that, you simply have AX multiply by what? BY. And what are we seeing? I and what? J. So basically this is what? I dot what? J. Am I communicating? Now let's move to the last one. The last one will simply be what we have here multiplied by this. So if you do that, you simply have what? AX multiplied by what? BZ, right? What I have in I and what? K. So basically this is what? I dot what? K. Now let's go to the next one. This is the next one. Now remember what we have here is basically what? Plus, because this is the sign we have here. The next one is we are coming to what? AYI, multiplying everything in this bracket. Now if you do that, you simply arrive at what? AY multiplied by what? BX, right? Then you now have you have J multiplied by what? I. So this is J multiplied by what? I. Plus, what's the next one? The next one is this. So we are using this to multiply what we have here. So if you do that, you simply have AYBY, right? So what are you now having? J and J. So you have J dot what? J plus, so you have this multiplying what we have here. So if you have this multiplying what we have here, this will simply give you what? AY, right? You have I here, you have what? K here. So this is BZ J multiplied by what? K. Are we done? No. We are now going to use the last one which you have there to be what? AZK. Follow. If you have questions, drop it on the comment section. If you have the next one, which is what? AZK multiplying everything here. So we have AZK multiplying BXI. Now if you do that, this will simply give you what? AZ multiplied by what? BX. So what are you having? K multiplied by what? I. So this is what? K multiplied by what? I. Plus, what's the next one? BY. So you have AZ multiplied by what? BY. And what will it be? K multiplied by what? J. So basically you have K multiplied by what? J. Now what's the last one there? The last one is you are using this to multiply what we have here. Now if you do that, that will simply give you what? AZ, right? Plus what? AZBZ multiplied by what? KK. So basically this is K here and this is what? K here. So you have K dot what? K. Am I communicating? Is that all? No, that's not all. Now remember, we multiplied their unit vector separately from what? From the magnitude. Am I communicating? Now what is the magnitude? This is the magnitude and these are what? The unit vector, right? Now look up. Those ones I gave you a condition. I said same unit vector multiplying itself, you have 1. But when they are not the same and they are multiplying itself, you have what? 0. Now let's come back to our solution. Look at this. Are they multiplying itself? Yes. So basically what you have here should be what? 1. Look at what you have here. So basically what are we having here? Here we can see that this is what? AXBY I multiplied by what? J. What's I multiplied by J? I multiplied by J is simply what? 0. This is what we have here. I multiplied by J is simply 0. So if I multiplied by J is 0, everything here will what? Be what? 0. Because everything here is just like a constant multiplied by what? 0. And it is what? 0. So everything here is going to quash out. This is what? 0. What's the next one? The next one we are seeing I and K. They are going to still quash out because they will give you what? 0. Am I communicating? What's the next one we are seeing? We are seeing j and I. J and I, they are not similar, they are not the same. J is not the same with I, so it will give you what? 0 here. What's the next step? The next step is we are seeing j and j. J and j is what? 1, right? So you have 1 multiplied by everything here, you still have what? AYBY. So we leave this to be. The next one is what? J and K. J and K will simply give you what? 0. Look at the next one. The next one is K and I. K and I will also give you what? 0, because 0 multiplied by everything here is what? 0. Now what's the next one? K and J. K and J also will also give you what? 0, because they are not the same. K is not the same with J. So basically that will give you what? 0 here. Now look at the last one. The last one is simply saying what? K multiplied by what? K, and that holds. So basically what you simply do is you are going to filter this, and we pick out those ones that we did not what? We did not take them to be 0, right? Now if you do that, you simply have AₓBₓ, this is 1 already, plus what's the next one? The next one is AYBY, so we have AY what? BY. What's the next one? The next one, this is 0, this is 0, this is 0, and the next one is what? Plus AZ what? BZ. Am I communicating? So basically you've simply arrived at this. You've simply arrived at this, and you can see that what we have here is just what? Magnitude without what? Direction. Am I communicating? So if you have magnitude here without direction, you can simply put it this way. Your final answer will now be, you can put it this way for a clear answer. You can put it this way: note there are what? Magnitude, but no what? Direction. That's the concept. So there are magnitude, but there is no what? Direction. That tells you that what you have here is basically what? A scalar what? Product. Looking at the example given, what are we seeing? We are basically asked from the example to show that A multiplied by B is a scalar product, or basically A multiplied by B is a scalar. Now how do you see a scalar? A scalar tells you that, okay, since this is a scalar, then it's going to have what? Magnitude without what? Direction. Am I communicating? So since we are going to see magnitude without direction, let's solve this example given. So we have A multiplied by what? B. So basically we are now asked to multiply, to show that A multiplied by B is a scalar and not a what? A vector. Am I communicating? Now how do we show that this is a scalar? Now remember, how I basically represent this in my exam is basically you take this to be what? AX, you take this to be what? AY, and you take this to be what? AZ. Here you take this to be what? BX. Here you take this to be what? BY. And here you take this to be what? BZ. So what do? You simply go back to your equation that you've already proved and know what you already have here as your scalar. So basically you have AX, BX, right? So let's come back and write our formula. So basically we have, you can write your formula here, AX, BX, right? Plus, what's the next one we have there? The next one is basically AY, BY, AᵧBᵧ, right? So you have AY, BY, so this is AY, BY, plus what? AᵧBᵧ. Am I communicating? So what you simply do is you apply this concept here and solve the question given simply. Now if you do that, what are we seeing here? We are seeing 10, right? So the first thing is AX multiplied by what? BX. Now what are we seeing here? We are seeing AX to be what? 10i, and we have BX to be what? 5i. So what you simply do is you go back to your formula and you input those values. So you have 10 multiplied by what? 5, right? What's the next thing? We simply have plus. The next thing is what? AY and BY. So we have ay here to be 7, by to be what? 6. So you have here, you now have what? 7 multiplied by what? 6. What's the next one? The next one is AZ and what? BZ. Now how do you go about it? So basically you have 13 times what? Times 2. That's the meaning. Now if you apply this concept and you punch your calculator, this will give you what? 10 times 5. I think that will give you 50. So you have 50 here multiplied by, what's the next thing here? 7 times 6. 7 times 6, I think this is 42. And plus 13 times 2, I think that's 26. So what you simply do is you punch your calculator, 50 plus 42 plus what? 26, and that will give you what? 118. Now look up. Your 118, is it having any direction attached to it as per your unit vector? No. What are we seeing? We are just seeing what? 118. So what's that telling you? That that's telling you that this is a what? This is a magnitude, just having a magnitude without what? Direction. And this shows you that this is a what? A scalar value. Am I communicating? Let's take down another example. Basically, if you have another example of this nature and we're asked to show that A multiplied by B is a scalar. Now, how do you go about it? The same concept, apply it here. You have A multiplied by what? B. So this will simply be what? What you have here multiplied by what you have here. So if you do that, you will simply arrive at what? 2 times what? 2 multiplied by, right? So you have 2 multiplied by, this is 2. So you are multiplying 2 with what? 3, right? So you have 2 times 3 plus what? 4 times 2. So this will be 4 times what? 2 plus the next one will be 6 times 5. So we have 6 times what? 5. Now what are you simply going to arrive at? This will give you what? 6 plus 4 times 2 will give you what? 8 plus 6 times 5. I think that should be what? 30. So if you have 38, 6 here, what do you think your final answer will be? So basically you punch your calculator, 6 plus 8 plus 30. And I think your answer is basically what? 44. 44. Now are we seeing any value or anything attached to your 44? No. That's telling you that your 44 has a what? Magnitude without what? Direction, which shows you that this is a what? This is a what? A scalar. Am I communicating?